Hello, this is our Camp 1 project for colligative properties. My name is Tristan.
My name's Michaela.
My name is Kevin.
And here's our presentation. So, for the goals for our colligative properties lab, the three main goals that we have, the first one is the solute concentration of our solution in relation to freezing and boiling point. The main goal is just to determine how concentrated and like how much solute can affect the freezing and boiling point. And our second main goal is calculating freezing points of pure solvents and solutions with added solutes, whether unknown or known. And then third overall is determining the molar mass from unknowns because we have certain formulas that we can use.
So colligative properties are the physical changes that happen whenever you add solute to a solvent. And so it depends on the amount of solute particles, not the identity of the solutes. The different types are boiling point, freezing point, and osmotic pressure. And freezing point depression is the absolute value of the difference between the freezing point of the solution and the freezing point of just a pure solvent.
So here are some of the equations that we used. By using the freezing point depression principle, we were able to determine the molar mass of the solute by using the new point and the original freezing point of the pure solvent.
So in our experiment, we set up an apparatus that showed the temperatures of pure water and an unknown solution over time. So first we recorded the temperatures of the unknown solution for a total of 3 trials, just so that we can approximate the temperature and the exact freezing point with the unknown solute. And then after we collected 10 data points, we did the average freezing points. And from these data points, we can use also the mass of the water and of the solute to determine the molalities of the unknown. And then also we can use our K water constant to determine the molar mass for each trial.
So this graph shows the freezing points of pure water and the freezing point of the solute. So as you can see, the solute's freezing point is much lower than just the pure water, which means that it can be liquid at a lower temperature than just pure water.
And then here's our data in a table. So the average molar mass was 191 grams per mole. Yeah.
And then from the 3 trials that we got and the 3 molar masses we got, the average was 91 or 191. So it was a lot closer to glucose, which we determined as the identity of our unknown solute. And that's it for our colligative properties lab. Thank you.
Thank you.
You.